Let's look at an example here for graphing tangent functions. So like we just did sine, we're going to look at functions of the form a tangent b times quantity x minus c. So I want to sketch the graph of y equals 3 times tan of 2x minus pi over 2 over a 1 period interval. Again, remember tan is a periodic function, so if I have the graph over 1 period interval, I can go ahead and, like I said, copy and paste that to get the entire graph of tan of x. Now, if you notice carefully, this is not exactly in the form of a tan bx minus c, right? So what I have right now is y equals 3 tan 2x minus pi over 2. So what I want to do is to get it in that form, first thing I want to do is I want to make sure that x has a coefficient of 1, right? And right now the coefficient of x is 2. So what I'm going to do is I'm going to factor out that coefficient. I'm going to factor out a 2. When you factor something out, you could think about dividing, right? So in a sense, if I'm factoring out a 2, it's kind of like I'm dividing everything in the parentheses by 2, okay? So I have y equals 3 tangent, right? I'm going to factor out my x. What am I left with? If it's 2x divided by 2, I'm just left with x. And then I have a pi over 2. If I divide that by 2, that makes it pi over 4, okay? So this function 3 tan 2x minus pi over 2 is the same as writing 3 tan 2 times quantity x minus pi over 4, okay? So again, let's figure out what a, b, and c are here. This is my a, this is b, and this is c, all right? So now step 1 here is we want to figure out the following. We want to figure out what is the stretch factor. We'll talk about that in a minute. We want to figure out what the period of the function is. So in a sense, when I say period, we want to see, has this function been compressed along the x-axis or has it been stretched along the x-axis? And then we're looking at the phase shift, which for us essentially is again nothing but the horizontal shift, right, in the left or right direction. So a is 3, okay, b is 2, and then c is pi over 4. So what is the stretch factor? Now notice, remember your graph of a tan function was something like that. So if I just draw this one cycle roughly for tan x, well, your graph was pretty much that. So there is no amplitude. There's no point in talking about amplitude because it's not like the graph goes up to a certain point. It actually goes all the way up to infinity and then going down all the way to negative infinity. So really, I mean, if you talk about amplitude, it's going to be infinity, which makes no sense here, right? So we don't talk about infinity, but what we look at is there a stretch? Now, if you think about your sine function, right? If my amplitude was, say, double, it would go twice the height. So in a sense, your amplitude was nothing but your stretch factor, right? How much am I stretching it by? Same thing here. If I stretch my function, right, it's going to become a little more linear-ish. Okay, so there's less of a curve now. That's a stretch for me. So I'm going to look at what is the stretch factor. And well, your stretch factor is nothing but in case of your sine and cosine, that was your amplitude. So my stretch factor is nothing but a, which is 3. Okay. Now, what is your period of the function? Period of the function is given by, in this case, pi over b. Remember, for sine and cosine, it was 2 pi over b because the period of a sine function is 2 pi. The period of a tan function, however, is pi. So this is pi over b, which is pi over 2 for us. So again, this is a compression. You're sort of getting this in half the distance, right? So it's going to be a compression. So think about this as a compression. Okay. And then finally, what we have is our horizontal shift, or what we call the phase shift. And that's given by c, which is pi over 4. And since that's greater than 0, this is going to be shift to the right. Okay, so then comes step 2. Okay. What we're going to do in step 2 is basically we're going to locate two adjacent vertical asymptotes. Okay. And how are we going to do that, and why do we need to do that, first of all? So we saw that our function had a compression, right? Your period was, instead of being pi, the period of this function was pi over 2. So my function, first of all, right, this is, say, negative pi over 2 to pi over 2. In this length became half suddenly. And there was also a vertical shift of pi over 4. So this point has now moved by pi over 4, and this point also has moved by pi over 4, right? So these asymptotes have also moved, and how have they moved? We need to figure that out. So what we're going to do here is, we know when does, the thing is, when do we know we get an asymptote? I know I have an asymptote when I have tan of pi over 2, for example, because we know that's undefined. This is because cosine pi over 2 is equal to 0, so that's where my denominator becomes 0, right? And the same thing for negative pi over 2. So I'm going to take this thing in here, right, and I'm going to set it equal to pi over 2 and negative pi over 2, because if this angle is going to be pi over 2, then I know I'm going to get a vertical asymptote. So essentially what I'm going to do here is I'm going to take 2 times x minus pi over 4, that was our sort of the argument for tan, or the angle. Think about that as an angle for tangent. And I'm going to set that equal to negative pi over 2. And I'm going to do the same thing, and I'm going to set 2 times x minus pi over 4 equals positive pi over 2. And I'm going to solve for x. What is x going to be? So divide by 2, and I get x minus pi over 4 equals negative pi over 4. And then here, x minus pi over 4 equals positive pi over 4, okay? And then finally, I'm going to add pi over 4 on both sides. If I add pi over 4 on both sides, I get x equals 0. And if I add pi over 4, I get x equals pi over 2. So my two vertical tangents are now going to be at 0 and at pi over 2. Okay, so let's move on to step 3. Okay, so we found our 2 adjacent asymptotes. So we have from x equals 0, that's one asymptote, and x equals pi over 2, that's our other vertical asymptote. So what we're going to do is we're going to take that region, right? So we're going to take that interval from divide the interval 0 to pi over 2, and I'm going to divide that into 4 equal parts, right? This is kind of the same thing we did with sine and cosine functions, if you remember. So I'm going to divide this into 4 equal parts. Okay, so how am I going to do this? I'm going to do this by, and this is going to be of length 1/4 of the period, which is pi over 2. So basically, each of this part is going to have a length of pi over 8. Okay, so if you remember what we got in sine and cosine, we got 3 critical points right in the middle, that sort of at the distance 1/4, 1/2, and 3/4. We're going to get something similar here. So I'm going to start with 0. Okay, obviously I have a vertical asymptote here, and then I'm going to add pi over 8. Well, that gives me pi over 8. Okay, then I'm going to take pi over 8. I'm going to add another pi over 8 to it, and so that gives me pi over 4. Okay, and then I'm going to take this pi over 4, add another pi over 8, and that's going to give me 3 pi over 8. Okay, and then finally I'm going to take that 3 pi over 8, add another pi over 8, and that's going to give me 4 pi over 8 or pi over 2, right? So these two, this one here and this one here, we know those are our vertical asymptotes, and so these are the 3 points that are going to divide that interval into 4 equal parts. Okay, and now what I'm going to do is I'm going to go ahead and compute the values, right? So I'm going to go ahead and make my table. So this is x, and this is y, equals basically 3 times tan of 2 times x minus pi over 4. Okay, and I'm going to compute the values at these points. So if I compute the values of these points, I'm going to get at pi over 8. So remember, at 0 and pi over 2, it's going to be undefined because that's where our vertical tangent lines. So at pi over 8, if I put it in this function, I get the value -3. If I put in pi over 4, I get the value 0. So that's my x-intercept. And at 3 pi over 8, okay, that's where I'm going to get +3. Okay, so take a look at these, and then we're going to go ahead and graph our function. Okay, so finally we have the last step 4, and that is going to be graphing. Right, so let's go ahead and graph that function. So let's go ahead and draw our y-axis first. And then this is our x-axis. Remember, again, we want to graph only one cycle. And our one cycle was from 0, right? That's where I had my asymptote, my vertical asymptote. And then to pi over 4. So I'm going to go ahead and to pi over 2, I'm going to divide that into 4 parts. So this was our point pi over 8. This was our point pi over 4. This was 3 pi over 8, and then finally we had pi over 2, and also again at pi over 2 I had a vertical asymptote. Okay, at pi over 4 we had 0, at pi over 8 we had -3, so let's say this is -3. Okay, and then at 3 pi over 8 we had about +3, so let's say about here is +3. Okay, and so then my function is going to look something like that. Okay, so that would be the graph of the function y equals 3 tan 2x minus pi over 2. Let's take a look at Desmos and see what the exact graph looks like. Okay, so here's our function again, 3 tan 2x minus pi over 2. Right, we already drew that on the board, so let's quickly take a look at that again. Now, so I typed the function Desmos here, so here is the graph, and as you can see now that basically what I have here is at pi over 4, right, my function is 0. This is my point 0, 0, and then I have an asymptote here at the point pi over 2. Okay, so this is one cycle. Now, how does this compare to our graph? Remember what I said, this was moved to the right by pi over 4, and then there was also a compression in the horizontal direction, and the length or the width of this function was reduced to half, right? So let's see if that holds. So here's a graph of tan, and as you can see, tan x is twice, right? Twice the width of this one cycle. Okay, also look at the 0, it's been moved to pi over 4 to the right, and also as you can see there's also a vertical stretch here, right? So this is the graph of y equals 3 times tan 2x minus pi over 4.